name of the transition metal, we would know what are the charges there. We don't have to memorize all of these, although these terms are still being used in chemical literature. So when you read the textbook there, it's something that you may want to pay attention to. When someone says ferrous oxide, you would know it's FeO. Ferric oxide would be Fe2O3. Okay, so that's naming for the binary compounds there. Now, for compounds, ionic compounds that involves polyatomic ions, remember one of the possible combinations for polyatomic ions is that when you have positively charged polyatomic ions versus non-metal elements or negatively charged polyatomic ion, you have an ionic compound there. So this part involves a lot more memorization, because for nitrite and nitrate, that represent different types of ions there. NO2, we call it nitrite. Okay, so sodium nitrite is NaNO2. NO2 bears one negative charge. NO3 also bears one negative charge. So that's where the confusion may come in there. And you may think NO3 and NO2, they should bear different types of charges there. But the reason, the actual situation there is that nitrogen has a different charge in NO2 versus NO3, and resulting in the same charge on the polyatomic ion. So this part, whenever the polyatomic ions are involved, you have to know the formula of the polyatomic ion. You have to know their charges there. So this part requires a lot more memorization there. And these are the common polyatomic ions. That's more than 16. And we have a list of 16 polyatomic ions, and this is something else in your textbook there. Now, there is quite a bit of overlapping between what we require you to memorize versus what we have here in your textbook there. And the least amount of memorization you have to do are those 16 polyatomic ions there. And this is another table that you can look at. And we have different types of polyatomic ions with the names in it. Okay? And so for oxygen-containing atom, and again, depending on the number of oxygen atoms there, so NO3 is nitrate, NO2 is nitrite. So SO4, that's sulfate. And you can see the similarity there. The ATE, when you end up with ATE, there's more oxygen in there. In this case, four oxygens in there in sulfate versus sulfite. Okay. Whenever you see an ITE at the end, it indicates less nitrogen atoms in there. And so nitrite, that's NO2 minus nitrate, NO3. And again, these things are something that you will need to get used to when you go through the nomenclature there. And there is simply no other way around. You have to know how we name them. And just like when you try to get to know a person, you have to know, first of all, what's their name, and then get to know one another a little bit better, and you know more details about the person there. Naming, nomenclature is one of the things that involves a lot of memorization. But if you look at the names repeatedly, you will memorize them quite naturally. So that's something that you want to pay attention to when you read the textbook there. So again, in your textbook, we give you the examples there and different types of compound, depending on how many oxygens we have there. Remember that chlorate, and when you end up with the 8 there, that's the normal form of the ion there. If you have more oxygen per chlorate, less oxygen, 1 less than the chloride, and then 2 less oxygen there, hypochlorite. So here, again, these are the things that when you read the textbook there, and these are the things you need to pay attention to. The nomenclature itself can seem to be very complicated. But there are only certain rules there that you have to memorize, and also hydrated ionic compounds there. When you have ionic compounds there, they would combine a certain amount of water with them. So magnesium hydrate would have 7 for each formula of magnesium sulfate. Magnesium sulfate hydrate, they would take 7 moles of water. Okay? So when you name the compound there, you have to make sure you indicate the number of molecules of water in there, and then you use the word hydrate to describe it. And talking about the hydrate, tomorrow when you go to the lab, and tomorrow and Thursday, we are asking you to determine the formula of a hydrate. and the title of the experiment is water hydration. We're trying to determine in molar ratio, how many moles of each ionic compound are associated with the number of moles of the water there. So we're asking you to determine this number here in our laboratory here. So you're going to get a little bit first-hand experience about working with the hydrates there. So that's another thing there. When you have ionic compounds there, they normally take some certain amount of water with them when the compound is formed. So we always have the possibility of having the hydrate and the anhydrous form of the salt. Now this happens when you have a magnesium sulfate, for example. If it takes water with it, if it forms hydrate, you end up with crystalline solid. If it doesn't have water in there, you end up with powdery solid. So there's a difference in the appearance there. Okay, so for hydrates there, also need to pay certain terms there. Mole means 1, di 2, tri 3, tetra 4, so on and so forth. Okay, so when you have a calcium sulfate, Hemi hydrate there, calcium sulfate, Hemi represent 1/2. So every molecule, every formula of calcium sulfate will take, well, every 2 formulas of calcium sulfate will take 1 mole of water. Okay, so the ratio here is at 1 to 1.5 ratio. Okay, and then every barium chloride will take 6 moles of water, or 6 molar molecules. So these are, now pay attention when you write the formula for the hydrate. There's a dot between the 2 formulas there. This dot actually represents a chemical bond that holds water molecule with the ionic compound there. This does not mean complication. Okay, and when we ask you to figure out the molar mass of this compound, you do barium plus 2 chlorine plus 6 H2O. And you don't multiply them. Okay, so for the hydrates there, that's the nomenclature, and that's something that we want you to pay attention to. In terms of molecular compound nomenclature, that's a different category. We try to separate ionic compounds from molecular compounds there. And when you try to represent the, when you try to name the molecular compounds there, you have to indicate, more than often, you have to indicate the total number of each element involved in there. So, for example, we can have a nitrogen monoxide, 1 nitrogen, 1 oxygen, nitrogen dioxide, 1 nitrogen, 2 oxygen, and dinitrogen monoxide, 2 nitrogens, 1 oxygen. Okay, so in your textbook there's again that color-coded nomenclature system there. That's something that we want you